Day 14 of 60. Here's an auth.log with 400 failed login lines scrolling past, and somewhere in that wall of text is an attacker hammering your SSH. Your CM is down. You've got a terminal and 2 minutes. Can you find them? By the end of this video you'll build a bash pipeline that extracts the attacker's IP, counts their attempts, and flags brute force candidates, using nothing but tools already on the box. No agent, no log shipper. Let's build it live. Start small. The signal we want is failed SSH logins, and OpenSSH writes a predictable line, failed password for invalid user admin from 203.0.113.5 port 44210. So grep first. Grep failed password /var/log/auth.log. That alone cuts 400 lines down to just the attack noise. But a list of raw lines isn't intelligence. We need the source IP, and we need to know who's the loudest. That's the next stage. Pipe into awk to pull the IP field. In that log line, the IP sits 3 fields before the end, so we use awk print $NF3. Why NF3 instead of a fixed column? Because the username changes length, invalid user admin versus just root, which shifts every absolute position. Counting backward from the end with NF, the number of fields, keeps the IP anchored no matter how the front of the line wobbles. Field-aware parsing beats brittle column numbers every time. Now we count. Append sort unique, C sort, RN head. Walk it left to right, sort groups identical IPs together, unique, C collapses each group and prepends a count, the second sort, RN orders by that count numerically and descending, and head shows the top offenders. Run it and one IP jumps out, 203.0.113.5 with 340 hits while everyone else has 2 or 3. That's your attacker, found in under 2 minutes from a cold terminal. But staring at a count isn't detection, it's still you doing the judging. Let's make the pipeline decide. Add a threshold filter, awk $1.10, print $2, $1. After unique, C, field 1 is the count and field 2 is the IP, so this prints only IPs with more than 10 failures, flip to IP first for readability. Anything that clears that bar is a brute force candidate by definition. You've just turned a human judgment call into a repeatable rule. Hard-coding a path and a threshold doesn't scale across a fleet, so wrap it in a function. Detect _ brute force, local log equals $1, local threshold equals $2-10, grep failed password \log awk, print $NF3, sort unique, C sort, RN awk, VT equals $threshold $1T, print $2 \T $1. Now detect _ brute force /var/log/auth.log 25 runs the whole chain with a tunable bar. The VT equals passes your shell variable into awk cleanly, and the tab separated output is structured, ready for a file, a report, or another pipe. Tab separated output is the bridge to real workflows. Redirect it, detect _ brute force /var/log/auth.log findings.tsv. Now wire it into cron to run every 15 minutes, */15******/opt/sec/detect _ bruteforce.sh/tmp/now.tsv. The trick is the diff, com-13, sort/tmp/last.tsv, sort/tmp/now.tsv, shows only IPs that are new since the last run. That delta is your alert. You're not rereading old noise, you're surfacing fresh offenders the moment they appear. That's a brute force detector, grep, awk, sort, unique, a threshold, and a cron diff, built from tools on every Linux box, working when your CM isn't. The big idea, Each pipe stage does one job and hands clean output to the next, so any stage is testable and replaceable. Day 14 done. Your takeaway: composable native tooling turns a wall of logs into structured findings with no agent at all. Subscribe for day 15, where we correlate these IPs against pseudo anomalies. See you there.